Okay, we are going to start talking about how to name branched hydrocarbons. And I really like the branched hydrocarbon idea because you think of the worksheet 1 and 2 without the branches as kind of like the tree trunk. So the first thing I want to do is just do this. So let's talk about the substituents. Let's do the easy ones first, the halogens. So we have fluorine, which has 7 valence electrons. And then we have chlorine, which has 7 valence electrons. And we have bromine, which has 7 valence electrons. And you know that every element wants 8. And we have iodine that has 7 valence electrons, and every element wants 8. And so in organic chemistry, well, in inorganic chemistry, this is called fluorine, and this is called chlorine and bromine and iodine. But in organic chem, when these hook on to the parent alkane or the trunk, um, this, oops, I did not mean to do that. This, the name for this is, fluoro. Fluoro. So, and this, instead of chlorine in organic chemistry, becomes chloro, and bromine becomes bromo, and iodine becomes iodo. Now, there is this weird thing. We've never done an odd electron system. This is the very first time I've done it because it's not on the AP. But here's an O, O, and I do ORP. And then this has 2, it wants 8. And this has 2, and it wants 8. And this has 4, and it wants 8. And when I do ORP, I get 20. But watch what happens when I do VE. VE is 5 plus 6 plus 6, which is 6, and 6 is 12, and 12 and 5 is 17. And so this is called an odd electron system. And what happens is you get this and this, but 2, 4, 6, 8, and then 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 17. This is called the free radical. It acts a lot like these did, because where you have this unpaired electron is where the covalent bond will form. And so what happens is you will see this guy a lot, NO2, because it's looking to form a bond here because it doesn't like to have this odd number. And so this is called nitro. The whole clump is called nitro because of the odd electron system. It's often put on as, I guess I shouldn't, odd electron molecule. I shouldn't call, yeah, it's just nitro. It's as a substituent. Okay, and then the other two substitute, there are a couple of things I want to talk about. This is methane. So this is methane. You know that from worksheet 1 and 2. If you take this hydrogen off, then this, and this hooks on to a, if you take this hydrogen off, this has to hook somewhere else. Methane becomes methyl. And so this is sometimes written like this. And then ethane is this, because eth means 2. And then this is called, let me come down here, this is called ethane. And but when you chop this off and you write it as a CH3, let's switch colors. That's this chunk, CH3, and then CH2, but we took one off. And then this means you yanked a hydrogen off and it's going to hook directly onto a parent alkane. And this is named as a substituent when that happens, ethyl. And weird things, you can even have this, like this is cyclopropane, because prop means 3. And so if you want to do this, this is how it really looks. Because remember, carbon wants to always form 4 bonds. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Because it's kind of hard to do that in a Word document, they'll do this, where the corners are the hydrogen. But this is called cyclopropane. But if you chop this off and this hooks onto a chain, it's named as a substituent, so cyclopropyl. So basically how this works is the ANE comes off and the YL goes on. Let's go here. The ANE comes off, methane becomes methyl, ethane becomes ethyl. Different though. Methane has 4 hydrogen, methyl has 3 hydrogen, and this dangling unpaired electron that wants to hook up with something and become an electron. All right, so basically you got a name. It's not that hard. Duffy mocks me because I read backwards. I see ANE first, and I think all single bonds, so I don't have to worry about any double or triple. And then I see pent, and pent means 5. So what I'm going to do is I'm going to go 1, 2, 3, 4, 5. If there's 5 atoms and they're in a line, there's 4 bonding sites. So pentane, and then this is 1, this is 2, this is 3, this is 4, this is 5. 2,2-dichloral. Oh, I forgot to tell you that. Let me go back a slide. This hasn't come up before. Let me do a slide. And on when this was on the AP, it never went over 4. So if you have two substituents, the prefix is di. If you have 3 substituents, the prefix is tri. And if you have 4 substituents, the prefix is tetra. And then the other thing it says, you can look in your blue packet, numbers are separated from numbers with commas. Numbers are separated from words by hyphens or dashes, whatever you want to call them. And everything else is just run together. So now I'm going to come back to here. I think this one. Ane, all single bonds. Pent means 5. Dichloral means 2 chlorine, and 2,2 means if this is di, there's going to be 2 numbers. It's like an address. So then I do this. After I do all single bonds, pent means 5. I put them in a line. Carbon always forms 4 bonds. This is the parent alkane. Just like your last name is more important than your first name. The parent alkane is pentane. 2,2-dichloral means we have 2 chlorines on the second carbon, and that's it. These dangling ones are assumed H's. Again, just like worksheet 1, you don't have to put them on, but you can. And so really worksheet 1 and worksheet 3 are pretty similar. It's just that you have these substituents. Okay, next one. Backwards. Ene means double bond. Double bond. Pent means 5. And the 2, notice this one didn't have a number by the pentane. Well, you don't have to give the position of a single bond. 2 pentane. Ene means double bond, pent means 5, and 2 means that you have the 5 pent. If there's 5 atoms, there's 4 bonding sites, and 2 means there's a double bond in bonding site 2. That takes care of this. Then carbon wants 4, so this is going to have 3. 1, 2, 3. This is going to have 1. 1, 2, 3. This is going to have 1. 1, 2, 3, 4. 1, 2, 3, 4. Fluoro, trifluoro means 3 fluorine, and 3,4,4 means 1's on 3 and 2 are on 4. And then the rest of these are hydrogens. I don't care if you leave them blank, but that is what that molecule looks like. And again, read them backwards. This one, ane means all single bonds, hex means 6, and cyclo means in a circle. So 1, 2, 3, 4, 5, 6 in a circle. Okay, remember carbon wants 4, so 2, 4, 6, 8, 2, sorry, I just do 1, 2, 3, 4. I don't have to count by twos. Um, all right, so all single bonds, 6, cyclo means a circle, and methyl means, it comes from methane, it means this, and it hooks onto the, I put on the first one. Now notice there's no position because when you have a cyclical compound, and there's one substituent, it's assumed that it's in position 1. If you only have one double bond or one substituent, it's assumed position 1. Now, nobody does this because we're lazy, so let me just add a slide. What most people do there is they make a hexagon, and then at position 1, which I always have on the top, they hook a CH3. Or they make a hexagon, and then, or they'll just go C like this. 3 lines means 3 hydrogen, H3 means 3 hydrogen, whichever you like. Okay, now we're getting longer. Ene means double bond. Diene means 2 double bonds. Octa means 8. Notice they put an A here because octadiene doesn't flow off the tongue like octadiene. So if you have a di or a tri, you put an A in front of it. 2, 3 means diene, 2 double bonds. This is the position. So I'm going to do this. 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 carbons. There's 7 bonding sites. 1, 2, 3, 4, 5, 6, 7. I have 2 double bonds and they're at position 2, bonding site 2 and bonding site 3. And now I'm going to count. This carbon has 1, it needs 4. This carbon has 1, 2, 3, it only needs 1. This carbon has 1, 2, 3, 4, none. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Okay, now I'll just go backwards. 2, 3, octadiene. 2, 3, position 2, position 3, 8, because the di is touching the ene, it means 2 double bonds. So octadiene, that's done. 5 methyl, so 1, 2, 3, 4, 5. There's a carbon methyl group. And 1, 1 diiodo means on the first one, there's 2 iodine. And we're going to do naming tomorrow, but these are put in alphabetical order, not using the Greek prefixes. So iodine comes before methyl alphabetically. Okay, this one, backwards. YNE means triple bond. Hept means 7, and 3 means this triple bond is at 3. So I'm going to go hept 1, 2, 3, 4, 5, 6, 7. 6 bonding sites. 1, 2, 3, 4, 5, 6. There is a triple bond in bonding site 3. 1, 2, 3. Boom, boom. Now that's the parent. And before I put the substituents on, I'm going to just go 1, 1, 2, 3, 4. This has 1, 2, 3, 4. This one has 1, 2, 3, 4. Don't add any hydrogen. 1, 2, 3, 4. Don't add any hydrogen. This one add 2. This one add 2. This one add 3. And now we have butyl means 4, and cyclo means in a circle, and 2 means on position 2. And the best way to do that is have it come into the corner of a square. Has to come into the corner because it's the vertices that represent the carbon. And that's that picture. And here's the last one. Ene means double bond. Pent means 5, and cyclo means in a circle. So I'm just going to do a pentagon. Okay, that's a really bad pentagon. Let me grab the eraser. So just draw a regular pentagon, like make your geometry teacher, Mrs. Hires, proud of you. Let's do a regular pentagon. Pent, cycloene means there's a double bond, and this is how you show a double bond. And this then, double bonds are more important than substituents. This, I'm going to come back and erase this. But this, I'm going to go 1, 2, 3, 4. I'm going to think of it like this because the most important thing, which is the double bond, is in position 1, bonding. So bonding site 1 is between atoms 1 and 2. Bonding site 2 is between atoms 2 and 3. Okay, so ene, double bond, pent, 5, cyclo in a circle, and then 3-fluoro means on this fourth one, there's a fluorine. I should go back to blue. I'm going to redraw this. There's a fluorine. And then 1 means on this one, there's an ethyl group, which you can either do like this, or you can do like CH3, CH2, CH3, and then okay, so there's 1, 2, 3, 4, 5. So cyclopentane, if this wasn't here, but then it's cyclopentene, and this is in position 1. It's a 1, 2, 3, 4, or you could go 1, 2, 3, 4, but either way, it's the same picture. I like this picture the best. If you really wanted to be obnoxious, you could go 1, 2, 3, 4, 5 in a circle, and then this is bonding site 1, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, 3, 4, and then on this 1, 2, 3, 4, on this one you put the fluorine, I think, and on this one you hook a methyl group, which is a, oops, a little tiny chain of 2. I don't like this as much. I prefer, but I've been doing this a long time. I just think this looks a little cleaner. CH2, CH3. There's your ethyl, there's your fluoro, there's your double bond. That's not the one. Which one am I drawing? Yeah. Okay, that's it. Give it a shot. Just got to figure out how to stop this.